I'm Margaret Livingstone. I'm a professor of neurobiology at Harvard Medical School. I'm a visual neurophysiologist, which means that I try to figure out how we see by recording from neurons at various levels in the visual system. But I've come to realize that artists also try to figure out how we see. And many works of art are important because artists have revealed important things about how we see. Now, I know that a lot of works of art are important because they reveal things about human psychology or human culture, but I work on low-level vision, so I'm going to talk about works of art that reveal important things about the way our visual systems work. So your visual system starts in the retina, projects to the primary visual cortex, and then it splits into these two major processing streams. The ventral stream in your temporal lobe carries information about what objects are. So we call this the what part of our visual system. And this part of our visual system is a primate add-on to the evolutionarily older basic mammalian visual system, which is represented more by our dorsal stream, which we call our where system. It carries information about motion, depth, spatial organization, and figure-ground segregation. It does all the kinds of things you'd expect a basic visual system to have to do in order to allow you to navigate through your environment and grab things or see things that are moving. And here's some drawings made by patients with parietal lobe lesions. They were asked to draw a bicycle, a cross, and a clock. And you can see they get all the bits right, but the bits aren't in the right spatial organization. Kind of like a cubist drawing. This is not to say that Picasso had a parietal lobe lesion, but rather that he cottoned on to the idea that what and where are very different things. And I think he also cottoned on to the idea that we recognize objects from all different points of view at the same time. And that part of our visual system probably has little snippets of parts of objects that are plastic in how they can be put together, because they need to be, otherwise we couldn't recognize the same object from different points of view. If you look at neurons throughout the brain, not just the visual system, but everywhere in the brain, all of the cells that project long distances are excitatory. Inhibitory neurons are always local. So local inhibition produces a number of effects in contrast. So artists know that your visual system cares about contrast. And that's the whole basis of chiaroscuro. And Monet takes advantage of that by making the sun look much brighter than the whole sky by having local darkness around the sun. It's so extreme, it's almost a caricature, and yet it's still very effective. The sun looks brighter than the sky, but it's actually exactly the same brightness. Artists have ignored the laws of physics for centuries because your visual system doesn't go around making sure that the laws of physics are being obeyed. You can assume the laws of physics are being obeyed. And artists have just ignored these things. In Canaletto's Piazza San Marco, the shadows on this side of the piazza go that way, and the shadows on this side of the piazza go that way. And when I pointed this out once, a curator came over and said, well, that's because light is coming over here and reflecting off that building and causing the shadows to go that way. So I went to the Piazza San Marco, and this building is just columns and doors and windows. It doesn't shine enough light, it doesn't reflect enough light for there to make shadows, and there is no time of day in the Piazza San Marco when the shadows go in two different directions. But nobody cares. Your central vision is very good at seeing high spatial frequencies, little tiny things. And your peripheral vision isn't just a bad version of your central vision, it's actually better at seeing big, blurry things. So I think one of the things the Impressionists figured out is that less is more. So if you don't have a lot of detail in your paintings, every time you move your eyes around, the viewer finishes the painting in a different way. So if you look closely, you can barely tell what these things are. Are they people? Are they tables? Are they horses? And yet, as you move your eye around, your visual system makes sense of the whole painting, but every time you move your eye in a different way, you make sense in a different way. So the painting looks different. It changes as you move your eyes around the painting, again giving a dynamic quality to a static painting. So vision is information processing, and computations are simple, local, and opponent, even for something as complicated as depth perception. So you look out in the world, it looks vividly three-dimensional. And I know it is three-dimensional. I'm not going to deny that. But you see it as three-dimensional based on two flat retinal images. One of the ways that we see depth is from the difference in the images in your two eyes. So this is stereopsis. Some people have it, some people don't. It's based on the fact that when you look at an image, it casts images on corresponding parts of your two retinas, but anything that's closer or farther away from your plane of fixation casts images on non-corresponding parts of your two retinas. And your visual system uses those tiny differences between the two images on your two retinas as part of its computation of distance and depth. So when you're looking at a painting where the artist has incorporated a lot of cues to depth, such as perspective and shading and occlusion, your stereo system, if you're looking at the painting with both eyes, contradicts those cues and tells you that the painting is actually flat. So if you want to see all the depth that the artist put into a painting, stand right in front of it so it fills your visual field and close one eye, and you'll feel like you're falling into the painting. I think the dynamic vibrancy of pointillist paintings comes about because with your central vision you see the dots, with your peripheral vision you see the boats and the reflection, and so on. And as you move your eyes around the painting, which you have to do necessarily, this is an obligatory part of your visual system, is that you move your eyes several times a second. As you move your eyes, what looks like dots and what looks like boats and river changes. And again, that's a dynamic quality. And it's like real water, because if you're looking right at the reflection, you see dots. If you're looking a little bit farther away, you see the mass. And if you look still farther away, you see the solid reflections. And that's what real water does. So Chuck Close takes this idea even farther. His portraits are usually huge, and they're made up of tiles of different colors or different luminances. And with your central vision, you see the tile, and with your peripheral vision, you see the portrait. And here's a miniature one, again, made up of smaller elements. Your central vision sees the elements, your peripheral vision sees Philip Glass. So if you get anything out of what I'm telling you today, I hope you get the idea that vision is information processing, not image transmission. It doesn't do you any good to transmit a high-resolution image to the back of your head because there's nobody up there to look at an image. All you have up there is neurons. All they can do is fire and not fire.